So is human intelligence going to be the upper limit of what's possible? I think absolutely not.
I do wonder what all of this means for people. I mean, if we are getting to a point where essentially, human intelligence is dwarfed by superintelligence, what does that mean for society?
It means a massive transformation. This is actually something which is going to structurally change the economy and society and all kinds of things. And we need to think about how do we structure this new world.
Welcome to Google DeepMind, the podcast with me, your host, Professor Hannah Fry. AGI is coming. That's what everyone seems to be saying. Well, today, my guest on the podcast is Shane Legg, Chief AGI Scientist and co-founder of Google DeepMind. Shane has been talking about AGI for decades, even back when it was considered, in his words, the lunatic fringe. He is credited with popularising the term and making some of the earliest attempts to work out what it might actually be. Now, in the conversation today, we're going to talk to him about how AGI should be defined, how we might recognise it when it arrives, how to make sure that it is safe and ethical, and then, crucially, what the world looks like once we get there. And I have to tell you, Shane was remarkably candid about the ways that the whole of society will be impacted over the coming decade. It's definitely worth staying with us for that discussion. Welcome to the podcast, Shane. We last spoke to you 5 years ago, and then you were telling us your sort of vision for what AGI might look like. In terms of the AI systems that we've got now today, do you think that they're showing little sparks of being AGI?
Yeah, I think it's a lot more than sparks.
More than sparks?
Oh, yeah. So my definition of AGI, or sometimes called minimal AGI, is it's an artificial agent that can at least do the kinds of cognitive things people can typically do. Yeah. And I like that bar because if it's less than that, it feels like, well, it's failing to do things cognitive things that we'd expect people to be able to do. So it feels like we're not really there yet. On the other hand, if I set the minimal bar much higher than that, I'm setting it at a level where a lot of people wouldn't actually be able to do some of the things we're requiring of the AGI. So, we believe people have some sort of, general intelligence, you might call it. So it feels like if an AI can do the kinds of cognitive things people can typically do, at least, possibly more, then we should sort of consider it within that kind of a class.
The stuff that we have now, where is it on those levels?
Right. So it's uneven. So it's already much, much better than people, let's say, speaking languages. So it'll speak 150 languages or something. Nobody can do that. And its general knowledge is phenomenal. I can ask it about, the suburb I grew up in, a small town in New Zealand, and it happens to know things about it, right? On the other hand, they still fail to do things that we would expect people to typically be able to do. They're not very good at continual learning new sort of skills over an extended period of time. And that's incredibly important. For example, if you're taking on a new job, you're not expected to know everything to be performant in the job when you arrive, but you have to learn over time to do it. They also have some weaknesses in reasoning, particularly things like visual reasoning. So the AIs are very good at, say, recognizing objects. They can recognize cats and dogs and all these sorts of things. They've done that for a while. But if you ask them to reason about things within a scene, they get a lot more shaky. So you might say, well, you can see a red car and a blue car, and you ask them which car is bigger. People understand that there's perspective involved, and maybe the blue car is bigger, but it looks smaller because it's further away, right? AIs are not so good at that. Or if you have some sort of diagram with nodes and edges between them.
Like a network. A
network, yeah, or a graph, as a mathematician would say. And you ask questions about that, and it has to count the number of, edges, spokes that are coming out of, one of the nodes on the graph. A person does that by paying attention to different points and then actually mentally maybe counting them or what have you. The AI is not very good at doing that type of thing. So there are all sorts of things like this that we currently see. I don't think there are fundamental blockers on any of these things, and we have ideas on how to develop systems that can do these things, and we see metrics improving over time in a bunch of these areas. So my expectation is over a number of years, these things will all get addressed, but they're not there yet. And I think it's going to take a little bit of time to go through that because it's quite a long tail of all sorts of cognitive things that people can do. where the AIs are still below human performance. As we reach that, and I think that's coming in a few years, unclear exactly, the AIs will be a lot more reliable, and that will increase their value quite a lot in many ways. But they will also, during that period, become increasingly capable, like to professional level and beyond, and maybe in coding, mathematics, already in knowing multiple languages, general knowledge of the world, and stuff like this. So it's kind of it's an uneven thing.
If you think that they will become more reliable over time, like how? Is it just a question of making the models bigger, doing things at a larger scale? Is it more data? I mean, do you have a clear path to make them more reliable?
I think we do, and it's not one particular thing. It's just not bigger models or more data. In some cases, it's more data of a particular kind, and then when you collect data that requires that, say, visual reasoning, then the models learn how to do it. In some cases, it requires algorithmic things, like new processes within. So, for example, if you want to do continual learning, so the AI keeps learning over time, you might need some process whereby new information is maybe stored in some sort of retrieval system, episodic memory, if you like, and then you might have systems whereby that information over time is trained back into some underlying model. So that requires more than just more data. It requires some sort of algorithmic and architectural changes. So I think the answer is a combination of these things, and it depends on what the particular issue is.
I know that you don't think that AGI should be this single yes/no, like a threshold that you cross, but more of a sort of spectrum, as it were, that you have these levels. Just talk me through that.
Yeah, so I have what I call minimal AGI, and that's when you have an artificial agent that it can at least do all sorts of cognitive things that we would typically expect people to be able to do. And we're not there yet, but it could be 1 year, it could be 5 years. I'm guessing probably about 2 or so.
So that's the lowest level then?
That's
minimal AGI.
What I call minimal AGI. That's the point at which I'd say, okay, this AI is no longer failing in ways that we would find surprising if we gave a person that cognitive task. And I think that's the minimum bar. Now, that doesn't mean we understand fully how to reach the capabilities of human intelligence, because you can have extraordinary people who go and do amazing cognitive feats, inventing new theories in physics or maths, or developing incredible symphonies, or writing amazing literature and so on. And just because our AI can do what's typical of human cognition doesn't necessarily mean we know all the recipes and algorithms, everything required to achieve very extraordinary feats of human cognition. Once we can, with our AI, achieve the full spectrum of what's possible with human cognition, then we really know that we've nailed, at least fully to human level. And so we call that full AGI.
And then is there a level beyond that?
So I think once you start going beyond what is possible with human cognition, you start heading into something that's called artificial superintelligence, or ASI. There aren't really good, clear definitions of that. I've actually tried on a number of occasions to come up with a good definition of that. And every definition I've ever come up with has some sort of significant problems. But at least in vague terms, it means something like it's an AGI, so it has the generality of an AGI, but it's now so capable in general, it's somehow far beyond what humans are capable of reaching.
Because I know that you were one of the people who helped to coin that phrase, AGI. Do you think that it's still useful as a phrase? I mean, there's so many competing definitions now. It's sort of like the buzzword that everyone's using. And you're right that it's sort of, the way that it's described is almost like a yes-no, like a kind of discrete line that gets crossed, rather than this continuum almost of levels as you're describing. Yeah.
So when I proposed the term, I was thinking of it more as a field of study. Because I was talking to a guy, Ben Goertzel, who I'd worked for a year or so before, and he wanted to write a book on sort of the old vision of AI, the sort of thinking machines, these machines that can do lots and lots of different things, rather than it's just specialized, it just plays poker, it just does text-to-speech, it just does, very, very specific things, which were sort of typical at the time. I was like, what about the old dream of AI? Building a system that has a very general capability, and it can learn and reason and do language and write poetry or do maths or maybe paint a picture or, all sorts of different things. What do we call that? And I said to him, well, if it's really about the generality we want, why don't we just put the word general in the name and call it artificial general intelligence? AGI kind of rolls off the tongue. Maybe we do that. But then what happened is that a number of people started using the term online, and then very quickly people started talking about, well, when will we have AGI? And so then AGI moved from being a sort of field of study or a subfield to a category of artifacts, right? And then it needs a definition. So perhaps it was a mistake that I should have gone in and defined it, there. Now, it turned out a few years later, we found there was a guy, Mark Brudd, who had actually written a paper in 97 where he'd used the term, but it was in a nanotech security conference, and none of us knew about this. But the way he defined it was actually in reference to the sorts of cognitive things people do in industry and other places like that. So it's quite similar flavor to even what I'm using now. Now, yeah, if it had been fixed more clearly early on, that would be helpful.
Do you regret coining the term?
No, because I think it gave a way for people to refer to this idea of building AIs that were actually general. Or at least as general to the extent that people's, intelligence is general. There was a need for that, I think. And that's why I think the term caught on, because there was sort of, how do you refer to that if you're not referring to this? If people use phrases like advanced AI, well, AlphaFold is an advanced AI in some sense, right? And it's very impactful, but it's very, very narrow, right? Or AlphaGo, again, it's very narrow and it's some sort of advanced AI system. So how do you refer to systems that are very general? But then what's happened is that different people saw the term and took on, they adapted it in different ways, or they looked at it through different lenses. So for some people, back even in the early days, when they thought of AGI, thought of something in the future, decades away, and that this would be very transformative. And so they started thinking about AGI in terms of the transformation it would create in society. And so then they started, if they try to define it, they tend to think about, it's because it's going to lead to, economic growth, or it's going to do all these sorts of things, right? I tend to think of it as more of an historical point in time. It's the point in time at which we sort of have to say, well, these AIs in some sense belong in a similar category to our intelligence, in that they can do cognitive things that we typically can do. Now, that doesn't necessarily revolutionize the world. The typical person walking around isn't going to be a Mozart or an Einstein and invent the successor to quantum theory or whatever, right? But it's a very interesting point in time, because 10 years ago, 20 years, whatever, we did not have AIs that were anywhere close to being able to do the cognitive things that people can typically do. So I think this is an important sort of historical moment, in that AIs are somehow in a similar category to us. I also think, and I think it's useful to try to define it a bit, because one of the issues that come up is people have these different timelines, right? Some people say, AGI, I think it's going to be here in 3 years. I think it's going to be 15 years away or 20 years or whatever. And often when I go and talk to them about that, I find that they're using a different definition. And so that just leads to a lot of confusion, because people use the term to mean different things. And in some cases, I actually agree with what they think is going to happen. They're just using the word in a different way, and that just creates quite a lot of confusion.
I just want to compare some of the other definitions that people are using for AGI. So some people have suggested that it's like there's a checklist of tasks, or maybe there's humanity's last exam, which is this sort of language model benchmark of 2,500 questions across different subjects, so humanities and natural sciences. There's other people that have said, it needs to be able to perform in a kitchen. It's sort of trained as a chef and be able to be dropped into a different kitchen and perform. Or there's even one which is, could it be able to make $1 million from $100,000?
Yes.
What's your take on those definitions?
Well, each one I have a take on.
Go ahead.
So we have to go through them. Make was $1 million from $1,000 or something around that. That's obviously a very economic kind of perspective on it. I think a lot of people would struggle to do that. it's a very, I think in some ways, quite narrow perspective on this. I mean, maybe you could have, I don't know, a trading algorithm that trades on the markets that could do that, but that's all it can do. That's not what I'm talking about. So I think it's the G, that's the G in AGI. It's the generality that I find interesting. And I think that's one of the incredible things of the human mind is our flexibility and generality to do many, many different things. If you have a particular set of tasks, well, okay, maybe you can build a system that can do those tasks, but maybe it's still failing to do basic cognitive things that we'd expect almost anybody to be able to do. I think that's unsatisfying. It's like, oh, our AI just failed again because it doesn't understand that really simple thing that I would expect pretty much anybody to understand. So the way I would operationalize my definition is I would have a suite of tasks where I know what typical performance is.
From humans.
And I would see whether the AI can do all those tasks. Now, if it fails at any of those tasks, it fails to meet my definition.
Because it's not general enough.
Yeah, it's failing to do some cognitive thing that we'd expect people to be able to do. If it passes that, then I would propose we then go into a second phase, which is more adversarial. And we say, okay, it passed the battery of tests, so it's not failing at anything in our standard collection of however many thousands of tests or whatever we have. Now let's do an adversarial test. Get a team of people, give them, I don't know, a month or two or whatever. They're allowed to look inside the AI, they're allowed to do whatever they like. Their job is find something that we believe people can typically do, and it's cognitive, where their AI fails at. If they can find it, it fails by definition. If they can't, after a few months of probing it and testing it and scratching their heads and trying to find it, I think for intensive purposes, most practical purposes, we're there. Because the failure cases are now so hard to find, even teams of people, after an extended period of time, can't even find these failure cases.
Do you think that we'll ever agree on a definition of what intelligence is or AGI is indeed?
In terms of AGI itself, my guess is that some years from now, the AIs will become so generally capable in so many different ways, people will just talk about them as being AGI, and AGI will just happen to mean those things. And maybe people will be less worried about, they will have less arguments about whether this is an AGI or not. People will say, oh, I've got the latest Gemini 9 or whatever it is. And it is really good. It can write poetry. You can teach it a card game and it can play with you that you just made up. It can do math. It can translate things. It can plan a holiday with you or whatever, right? It's really, really generally capable. And it'll just seem obvious to people that it has some sort of generality of intelligence.
But then for now, I mean, in terms of before we get there, having this kind of defined path on the route to AGI, I mean, you talk about the risks of not having one, that it could like acquire a certain piece of knowledge before another. For instance, I don't know, like being good at chemical engineering before it gets really good at ethics. I mean, how important is it to have this work now in advance of getting there?
So work around understanding its capabilities in different dimensions. I think it's very important because we have to think about how do we, being society, navigate the arrival of powerful, capable machine intelligence. And you can't just put it on a single dimension. It may be superhumanly capable at some things. It may be very fragile and weak in some other areas. And if you don't understand what that distribution looks like, you're going to not understand the opportunities that exist. You're also not going to understand the risks or the ways in which it could be misapplied because, it's super capable over here, but you need to understand that it's very, very weak over here. And so certain things can go wrong. So I think it's just an important part of society navigating and understanding what the current situation is. So, I think a lot of the dialogue around AI already tends to talk about as being so capable or sort of being not really that capable and it's overhyped or whatever. I think the reality is much more complicated. It is incredibly capable in some ways, and it is quite fragile in others.
You have to take the whole picture, essentially.
You've got to take the whole picture, yeah. And it's like, human intelligence as well. Some people are really, really good. They speak a whole bunch of languages. Some people are really good at math. Some people are really good at music, but maybe they're not so good at something else.
So, okay, if we've sort of got performance and generality, the other sort of arm of this that I want to talk to you about is ethics. How does that fit into all of this?
There are many aspects to ethics and AI. One aspect is simply, does the AI itself have a good understanding of what ethical behavior is, and is it able to analyze possible things it can do in terms of this ethical behavior and do that robustly in a way that we can trust?
So the AI itself can reason about the ethics of what it's doing.
Yes.
How does that work then? How do you embed that within it?
I have a few thoughts on that, but it's not a solved problem. But I think it's a very, very important problem. I like something which some people call chain of thought monitoring.
Mm-hmm.
I've talked about this. I've given some short talks on it and so on. I call it System 2 safety. And
this is the Daniel Kahneman System 1, System 2 thinking.
Exactly. Thing. And so the basic idea is something like this. Say, as a person, if you're faced with a difficult ethical situation, it's often not sufficient just to go with your gut instinct, right? You actually need to sit down and think about, okay, this is the situation. These are the various complexities and nuances. These are the possible actions that can be taken. These are the likely consequences of taking different actions. And then analyze all of that with respect to some system of ethics and norms and morals and what have you that you have. And maybe you have to reason about that quite a bit to really understand how all this fits together, and then use that understanding to decide what should be done.
So let's say that the way that the human brain works in this situation, I mean, this is the Kahneman stuff, right, is that, someone annoys you, say, you have a rush of anger, you want to react. That's your System 1, sort of quick thinking, instinctive. Yeah. But you take a breath, you think it through, consider the consequences. That's your System 2 thinking, and then you might choose a different path.
Yes. So you might say, for example, I don't know, lying is bad, right? So we're not going to lie. But you could be in a particular situation where, I don't know, there's some bad people coming to get somebody, and if you tell a lie, you can save their life, and then the ethical thing to do is maybe to lie, right? And so the simple rule is not always adequate to really make the right decision. So sometimes you need a little bit of logic and reasoning to really think through, well, in this case, it is actually the ethical thing to do, is to tell a lie and maybe save someone's life or what have you, right? But it gets very complicated, and you have, you've probably heard of all these trolley problems and all these sorts of things, right? Where our instincts and the analysis in some cases start diverging and causes a lot of confusion, right? So this is not simple territory at all. And we have AIs now that do these thinking AIs, right? And so you can actually see the chain of thought that the AIs use. And so when you give an AI some question, it has a moral aspect to it, some ethical aspect, you can actually see it go away and reason about the situation. And if we can make that reasoning really, really tight and it has a really strong understanding of some ethics and morals that we want it to adhere to, I think it should, in principle, actually be able to become more ethical than people, because it can more consistently apply and reason at maybe a superhuman level the decision, these choices that it's faced with and so on.
Because that switches ethics into a reasoning problem, as it were, rather than just a sort of a feeling thing.
Yeah.
But then at the same time, I do wonder, when you're saying that, I do wonder a bit about grounding. I mean, these things, certainly for now, are like not living in the world as humans. Is it possible to sort of take what it feels like to experience the world from a human perspective and truly ground these machines in sort of human ethics?
Well, there's a few complexities. One complexity there is that there is not one human ethics.
Agree.
And there are different ideas about this that vary between people, but also between cultures and regions and so on. So it'll have to understand that in certain places, the norms and expectations are a bit different. And to some extent, the models do know quite a lot of this, actually, because they absorb data from all around the world. But yeah, it will need to be really good at that. In terms of grounding in reality, at the moment, we're building these agents by collecting lots of data from the world, training them into these big models, and then they become relatively static objects that we then interact with. And they don't really learn much new or anything like that. That's shifting, and we're bringing in more learning algorithms and all that kind of thing. But we're also making the systems more agentic. So they're not just a system that you talk to and then it processes and gives a response, but there may be a system that can go and do something. So you can say to it, okay, I want you to write some software that does such and such. Oh, I want you to go and, I don't know, come up with a plan for my trip to Mexico. And I want to see this and this, but I don't like this or whatever. And then those agents will also start to become more embodied in robotics and things like that. Some of them will be software agents, they'll do those sorts of things. But with time, I think they'll become more, they'll turn up in robots and all that kind of thing. And as you keep going along this track, the AIs become more connected to reality through all sorts of different things. And they actually have to learn through interaction and experience rather than just sort of a large data set that sort of goes in at the beginning. That's where the connection to reality tightens up a lot. That said, a lot of this data that was poured into them at the beginning, that came from somewhere. And a lot of it came from people. So there is a grounding to reality that comes via that process as well.
This idea of the AI being better at ethics than humans themselves, how do you, until you get there, until like the reasoning is as good as ours, how do you make sure that it's implemented in a safe way? I mean,
yeah, it's a big,
how
big
do you
question.
stop? I don't know. Like, so for example, a utilitarian argument, right, that works quite well for driverless cars on the roads is like you want to save as many lives as possible. But then in medicine, that same idea, right, it doesn't work anymore. You can't sacrifice one healthy patient to save the lives of 5 others. How do you make sure that it ends up reasoning in the correct direction?
You can't guarantee everything. The space of possibilities of action in the world is so huge that 100% reliability is not a thing. But it's not a thing in a lot of the world as it exists. If you need a surgery and you go and talk to the surgeon and you say, well, I'm going to get something removed or whatever, and the surgeon says to you, it's 100% safe, as a mathematician, you know that they're not telling you the truth.
Yes.
Right? Nothing is ever 100%. So what we have to do is we have to test these systems and make them as safe and reliable as possible. And we have to trade off the benefits and the risks. And we also have to, we have to do other things like monitor them. So when they're in deployment, we monitor them, keep track of what's going on. So if we start seeing that, there are failure cases that are beyond what we consider acceptable, we may have to roll back and stop them or do whatever, right? So there's a whole range of different things we need to do. We need to do testing before it goes out. We need to monitor it when they are out there doing things. We need to do things like interpretability. We're able to look inside the system. That's one nice thing about System 2. If it's safety, if it's implemented the right way, you can actually see it reasoning about things. But you've got to check that this reasoning is actually an accurate reflection of what it's really trying to do. But, if you have ways to look inside the system and really see why they're doing things, that can maybe give you another level of reassurance as to that they are sort of, trying to act in the right way. Because that's another important, subtlety. It's not always just about the outcome, but maybe the intention, right? So there's a big difference between, somebody hurting you intentionally and somebody, accidentally bumping you and it hurts or something, right? And we interpret that very, very differently. So if we can see inside our AIs, we might accept that, well, it was dealing with a tricky situation. It tried to do the best thing it could according to its analysis, but there was some negative side effect. We might be sort of okay with that because maybe even as people in that tricky situation, it would be very difficult for us to do the right thing. But if it did the wrong thing intentionally, that's a whole different thing. So these are all aspects of AI, AGI safety, and we have people working on all of these topics.
So then do you sort of limit the amount that these things can interact with the real world, how quickly you release them and so on until you feel confident that they're at this safety threshold?
Yeah, so we have all kinds of testing benchmarks and tests, and we run them, internally for a while, and we have particular things that we test for that are risky areas.
Like what?
We try to see if the system will help develop, like a bioweapon or something like that.
Right.
And obviously it should not.
Yes.
And so if we start seeing that we can somehow trick it or force it into being helpful in that area, that's a problem.
Right.
Hacking is another one. Will it help people, hack things and so on and so on. So yeah, we have at the moment a collection of these tests, and this collection keeps growing over time. And then we assess how powerful it is in some of these areas, and then we have mitigations appropriate to each level of capability that we see. It could mean that we don't release the model. It could mean that various different things depending on what we find, yeah.
Well, let's talk about the impact on society of some of this stuff, like once we get to really capable AGI.
Yeah.
And I know that this is something that you have thought an awful lot about. Is that fair to say?
Yeah. My main focus now is trying to understand what if we get AGI and it's reasonably safe for its level of capability, what about everything else? And the list of everything else is enormous. There are questions like, we've got powerful AGI and it's reasonably safe. Is it conscious? Is that even a meaningful question?
Do you have a stance on that right now?
Well, we've got a group looking at that, and we've talked to a lot of leading experts in the world who study this. And I think the short answer is nobody really knows.
To be absolutely clear, we're talking about full AGI here rather than the stuff we have at the moment.
Yes.
Are you comfortable that the stuff at the moment is not?
I don't think it is. As we go into some future AGI years 10 years in the future or something, which is very, very capable, will that system be conscious? When I talk to some of the most famous experts in the world that study this, there are various people who have arguments for, there are various people who have arguments against, but when I actually put a concrete scenario to them and I say, look, we've got Gemini 10 here and it's embodied in a humanoid robot, and it learns and it integrates information across sensors, and it can remember its own history as an agent in the world and do all these sorts of things. And also talks about its own consciousness, because you can actually get AI models to talk about their consciousness now if you prompt them in the right kind of way. Is it conscious? And when I put that to people in the field, they're like, well, I think probably not, or I think probably yes, but actually I'm not absolutely sure. And who knows, maybe we will have an answer to that. I think it's a long-standing question, and it's a very difficult question to even make into a strict scientific question because we don't know how to frame this as a measurable thing. What I am sure is going to happen is that some people will think they are conscious and some people will think they are not. That is certainly going to happen, particularly in the absence of a really well-accepted scientific definition and way of measuring it. And then how are we going to navigate that? That's a very interesting question as well. But this is just one question of
many.
We have things like, are we going to go from AGI, say full AGI, are we going to go towards superintelligence? That's far, far beyond human intelligence. Is it going to happen quickly, slowly, never? And if it does go to superintelligence, what is that superintelligence? What's the cognitive profile of that superintelligence? Are there certain things where it's going to be far, far beyond human? We already see it can speak 200 languages or something. That's clear. And are there other things where maybe because of the computational complexity or whatever, is not actually going to be much better than humans, right? Do we have any idea of that? That seems like a really important question for humanity to be thinking about. Are we going to go into superintelligence in a decade or 2 decades or something like that?
Do you have a stance on that? Do you think it will go to superintelligence? I'm sort of thinking here about Einstein, for example, came up with general relativity. Will we be in a position where you have AGI that can theorize about the world, come up with genuine scientific understanding that goes beyond what humans have managed?
I think it will, based on computation. And the human brain is a mobile processor. It weighs a few pounds. It consumes, I think, around 20 watts. Signals are sent within the brain through dendrites. The frequency on the channel is about order of 100 hertz or maybe 200 hertz in the cortex. And the signals themselves are electrochemical wave propagations. They move at about 30 meters per second. Okay. So if you compare that to what we see in a data center, instead of 20 watts, you could have 200 megawatts. Instead of a few pounds, you could have several million pounds. Instead of 100 hertz on the channel, you can have 10 billion hertz on the channel, right? And instead of electrochemical wave propagation at 30 meters per second, you can be at the speed of light, 300,000 kilometers per second, right? So in terms of energy consumption, space, bandwidth on the channel, speed of signal propagation, you've got 6, 7, maybe 8 orders of magnitude in all 4 dimensions simultaneously, right? So is human intelligence going to be the upper limit of what's possible? I think absolutely not. And so I think we, as our understanding of how to build intelligent systems develops, we're going to see these AIs go far beyond human intelligence. In the same way that, humans, we can't outrun a top fuel dragster over 100 meters, right? We can't lift more than a crane, right? We can't see further than the Hubble telescope. I mean, we already see machines in particular areas that can, fly faster than the fastest bird and all these sorts of things, right? I think we'll see that in cognition as well. We've already seen in some aspects, you don't know more than Google, right? And so on like information storage and stuff like that, we've already gone beyond what the human brain is capable of. I think we're going to start seeing that in reasoning and all kinds of other domains. So yes, I think we are going to go towards superintelligence. So that's why I'm very interested in things like System 2 safety, because if we can't stop the development towards superintelligence because of competitive dynamics globally and all these sorts of things, then we need to think really hard about how do we make a superintelligence super ethical. And if you have a system that can apply the capabilities of its intelligence, not just to achieving goals and doing things, but actually applying it to making ethical decisions as well, then it might scale with its capabilities in some way.
I do wonder what all of this means for people. I mean, if we are getting to a point where essentially, human intelligence is dwarfed by superintelligence, what does that mean for society? Does that mean just massive inequality, that you have the people who no longer have value essentially in what they can offer the economy being completely left behind?
It means a massive transformation. I think the current system where people contribute their mental and physical labor in return to access to resources that are generating the economy, that may not work the same anymore. And we may need different ways of doing things. Now, the pie should get much bigger. So there's not a problem of a lack of goods and services that are produced. If anything, that's getting much, much better. But we need to think carefully about what's the system for people? How do we distribute the wealth that exists in society? I think there needs to be a lot more thought going into this of how a post-AGI economy works and how the structure of a post-AGI society works as well. I gave a talk to the Russell Group Vice Chancellors. So in the UK, the Russell Group is the top universities in the UK. And I said to them, look, this AGI thing's coming and it's not that far away. In 10 years, we're going to have it. And it's going to start being able to do a significant fraction of all kinds of cognitive labor and work and things that people do, right? We actually need people in all these different aspects of society and how society works to think about what that means in their particular area. So we really need every faculty and every department that you have in your university to take this seriously and think, what does it mean for education, right? What does it mean for law? What does it mean for engineering, mathematics, city planning, literature, politics, economics, finance, medicine, ... right? So basically every faculty, every department studies something where human intelligence is a really important thing. And so if you have the presence of cheap, abundant, capable machine intelligence turning up, that thing needs to be thought about again. What is the implications of this? Should it be done in a different way? What are the opportunities? What are the risks, and so on? So I think there's an enormous opportunity here, but just like any revolution, like the Industrial Revolution or anything, it's complicated. It has all kinds of effects on society in all kinds of ways, and to get the benefits of that and minimize the risks and the costs of that, we need to navigate this carefully. And at the moment, I think nowhere near enough people are thinking about what AGI means for this particular thing. And we need a lot more people doing that.
Do you remember in March 2020 when the experts were saying, there's this pandemic coming, we're really standing on the edge of an exponential curve. And then everyone was still sort of in pubs and, going to football games and things. And the experts were increasingly shouting about what was coming. Do you sort of feel a little bit like that?
I remember those days well. It does feel a bit like that. People find it very hard to believe that a really big change is coming, because most of the time, the story that something really huge is about to happen, it's not always true. It fizzles out to nothing, right? And so as a kind of a heuristic, if somebody tells you some crazy, crazy big things are going to happen, as a heuristic, probably you can ignore most of those. But you do have to pay attention. Sometimes there are fundamentals that are driving these things. And if you understand the fundamentals, you need to take seriously the idea that a big change does come. And, sometimes big changes do come.
What does this mean, though? Because, you describe a sort of a long-term vision where you have full AGI and there's like prosperity that can, potentially be shared and so on. But getting there, we're talking about some really big, that's an understatement, massive economic disruption, structural risks here. Just talk us through what you expect the next few years to look like. Tell us what we didn't know in March 2020.
I think what we'll see in the next few years is not those big disruptions you're talking about. I think what we'll see in the next few years is AI systems going from being very useful tools to actually taking on more of a load in terms of doing really economically valuable work. And I think it'll be quite uneven. It'll happen in certain domains faster than others. So, for example, in software engineering, I think in the next few years, the fraction of software being written by AIs is going to go up. And so in a few years, where prior you needed 100 software engineers, maybe you need 20. And those 20 use advanced AI tools. Over a few years, we'll see AI going from kind of just a sort of a useful tool to doing really meaningful, productive work and increasing the productivity of people that work in those areas. It'll also create some disruption in the labor market in certain areas. And then as that happens, I think a lot of the discussion around AI is going to shift and become a lot more serious. And so it's going to shift from being just sort of like, oh, this is really cool. You can ask it to plan your holiday and help you with your, children's, if they're stuck in something and they don't understand their homework or whatever, things like this, through to something that's like, okay, this is not some nice new tool. This is actually something which is going to structurally change the economy and society and all kinds of things. And we need to think about, how do we structure this new world? Because I do believe that if we can harness this capability, this could be a real golden age, because we now have machines that can dramatically increase production of many types of things, right? And advance science and relieve us of all kinds of labor that maybe we don't need to be doing if the machines can do it, right? So there's an opportunity here. But that is only good if we can somehow translate this incredible capability of machines into a vision of society where there is some flourishing of people as individuals and as groups of people in society that benefit from all this capability.
Because in the meantime, you have those 80 software engineers who
Yes.
are no longer needed, and all of the other people, the entry-level employees at the moment, graduates who are sort of noticing that they're the first ones to be affected by this. Are there any industries that are not going to be impacted by this?
In the short to medium term, I think there'll actually be quite a lot of things. So plumber is often go to, right? I think in the coming years, we're not going, even if the AI does develop quite quickly, in its purely cognitive sense, I don't think robotics will be at the point at which it could be a plumber. And then even when that is possible, I think it's going to take quite a while before it's price competitive with a human plumber, right? And so I think there are all kinds of work which is not purely cognitive that will be relatively protected from some of this stuff. The interesting thing is that a lot of work which currently commands very high compensation is sort of elite cognitive work, right?
Yeah.
So it's people doing, I don't know, sort of high-powered lawyers that are doing complex merger and acquisition deals across the globe, and people doing advanced stuff in finance, or now people doing, advanced machine learning, software engineering, all these types of things.
Mathematicians.
Mathematicians. One rule of thumb that I quite like is if you can do the job remotely over the internet just using a laptop, so you're not some full haptic body suit with some robot, controlling whatever, just normal interface, keyboard, screen, camera, speaker, microphone, mouse. If you can do your work completely that way, then it's probably very much cognitive work. So if you're in that category, I think that advanced AI will be able to operate in that base to some extent. The other thing that is, I think, protective is even if it is sort of cognitive work, there can be a human aspect to some types of work and things that people do. So, for example, let's say you are, I don't know, an influencer, right? And you work, you can do that work maybe remotely, but the fact that you're a particular person with a particular personality and people know there is a person behind, what's going on there, that may be valuable in many cases, right?
That leaves a lot of people though, doesn't it?
I think what we need is sort of along the lines of what I suggested to the Russell group, is we need people who study all these different aspects of society to take AGI seriously. And my impression is that a lot of these people are not. And when I go and talk to people who are interested in one of these particular things, like, oh yeah, it's kind of like, it's an interesting tool, it's kind of amusing, whatever. But they haven't internalized the idea that what they're seeing now and any current limitations that they currently know of, which, by the way, are often out of date. Often these people say, oh, I tried to do something with it a year ago. It's like a year ago is now ancient history compared to what the current models are doing. And 1 year from now, it's going to be a lot better. They're not seeing that trend. In some ways, I actually think many people in the general public are ahead of the experts because I think there's a human tendency. If I talk to non-tech people about current AI systems, some of the people say to me, oh, well, doesn't it already have like human intelligence? It speaks more languages than me. It can do math and physics problems better than I could ever do at high school. It knows more recipes than me. It can help me with all kinds of things. I was confused about my tax return and explain something to me or whatever. They're like, so in what way is it not intelligent? This is the sort of thing that I get when I talk to a number of non-tech people. But often people who are experts in a particular domain, they really like to feel that their thing is very deep and special, and this AI is not really going to touch them.
I think I want to end with your now quite famous prediction about AGI. And you have stayed incredibly consistent on this for over a decade, in fact. You have said that there is a 50-50 chance of AGI by 2028.
Yes.
That's minimal AGI?
Yes.
Wow.
And
are you still 50-50 by 2028?
Yes.
And
2028. And you can see that on my blog from 2009.
And what do you think about full AGI? What's your timeline for that?
It's some years later. Could be 3, 4, 5, 6 years later. Yeah.
But within a decade?
Yeah. I think it'll be within a decade.
Do you ever just feel a bit nihilistic with all of this knowledge?
I think there's an enormous opportunity here. A lot of people put a lot of effort into doing a lot of work, and not all of it is that much fun. And I think there's an incredible opportunity here to, just like the Industrial Revolution, sort of took the harnessing of energy to do all sorts of mechanical work, which created a lot more wealth in society. Now we can harness data and algorithms and computation to do all kinds of more cognitive work as well. And so that can enable a huge amount of wealth to exist for people. And wealth, not just in terms of production of goods and services and so on, but new technologies, new medicines, and all kinds of things like this. So this is technology that has an incredible potential for benefit. Now, the challenge is, how do we get those benefits while dealing with the risks and potential costs and so on? Can we imagine a future world where we're really benefiting from having intelligence really helping us to flourish? And what does that look like? And that's, I can't just answer that. I'm very interested in that. I'm going to try and understand the best I can. But this is a really profound question. It touches on philosophy and economics and psychology and ethics and all kinds of questions, right? And we need a lot more people thinking about this and trying to imagine what that positive future looks like.
Shane, thank you so much. That was mind-expanding, to say the least. Humans are not very good at exponentials. And right now, at this moment, we are standing right on the bend of the curve. AGI is not a distant thought experiment anymore. What I found so interesting about that conversation with Shane is that he thinks the general public understand this better than the experts. And if his timelines are anything like correct, and he's had a habit of being right in the past, we might not have the luxury of time for slow reflection and realization here. We have got difficult, urgent, and potentially genuinely exciting questions that need some serious attention now. You have been listening to Google DeepMind, the podcast, with me, your host, Hannah Fry. If you enjoyed that conversation, please do subscribe to our podcast or leave us a review. Next episode, we are going to be sitting down with DeepMind co-founder Demis Hassabis. So trust us when we tell you, you don't want to miss that one.